Welcome back. My name is Elena and I am another one of your camp counselors for the Creativity and Coding VexCode VR camp. So previously you've learned about things like the bumper sensor and the distance sensor, and now we are going to move into learning about more sensors on the VR robot. The first one we're going to be talking about now is the location sensor. So the location sensor on the VR robot reports the X and Y position of the robot on the playground. So if you remember, we talked previously about how each of these playgrounds that we're using are 2,000 by 2,000 millimeters. Nice big square. But that means that we are going from negative 1,000 to positive 1,000 on the X and the Y axes. So let's take a look at a playground and see more about what I mean by the X and Y location. For the location sensor, we're going to be using the number grid playground. So let's go ahead and open up a new project. So we're going to go to File, New Blocks Project, and we'll scroll down to the number grid map. So this right here is just like the grid map. It's just not using numbers. So it's kind of similar to the art canvas, things like that, but it has numbers 1 through 99 on it. So let's go ahead and open the playground and take a look. So just like how we talked about with the bumper sensor, we have a dashboard where we can look at where sensor values are. So let's go ahead and open that again. We're going to open that by selecting this menu button here. We'll open our dashboard. And now we can look at this and we can see an option for location. So I can see currently that my VR robot, which is down here in the bottom left corner, is at negative 900 millimeters on the X axis and negative 900 millimeters on the Y axis. So I also have a printout here so I can show you a little bit about that axis. So we can see here, we have our X axis in red, our Y axis in blue going up, and every one of these squares is 200 millimeters apart. So you have 200, 400, 600, 800, 1,000, negative 200, negative 400, negative 600, negative 800, negative 1,000. So you can see that negative 1,000 to positive 1,000, negative 1,000 to positive 1,000 on both the X and the Y axis. So we're going to be using this to help us plan our projects. Let's go ahead and see the location sensor in action. So we can do that by running an example project. So an example project is just what it sounds like. It is an example of a project that you could create in VexCode VR. To open an example project, we're going to go to File, Open Examples, and because we are using a sensor, we're going to filter to our sensor category. So I can see here there's one that's light blue for sensing up at the top. If I select that, all of the examples that are shown now are sensor examples. So right here on the second line, I see location. So I'm going to open up the location example project. Let me go ahead and move my playground window. And I can see here an example of a project that we can write using the location sensor and a description of what this does. So what this project is doing is it's going to drive our robot along the X and the Y axes until it reaches the 0, 0 point. So let's go ahead and pull our project up here. I want to make sure that we're looking at the dashboard so we can watch those location values change. So as we run this example project, you can follow along with me, or you can just watch these values changing for this. So I'm going to go ahead and run my project. And now my robot's going to move up the Y-axis and then over the X-axis. And I can see here that my location now is 10 millimeters and 10 millimeters. So it's parentheses 10, 10. You might be asking yourself, well, Elena, you said it was going to drive to the 0, 0 location, not 10, 10. What's happening? And what's happening here, let me go ahead, I'm going to minimize this. We're going to move that down. Is that we are using greater than and less than operators to navigate our robot. So you can see here, we're using a lot of similar blocks of what we've used before. So we're going to drive forward, wait until the Y position is greater than 0. Then it moves on to the next block in the stack. Just like with the distance sensor, we don't want to use an equal sign because the robot might miss it. Our robot is moving very fast and it's constantly updating those sensor values. So using something like a greater than allows the robot to get as close as possible without going too far past, which is how we ended up with 1010. So let's watch this again and watch those location values. So we're going to see it's moving very rapidly along the Y, and it made it to 30 millimeters this time before it sensed. So you can tell there's going to be some slight variations here, but it's ending up at that 0, point or approximately at the 0, point on our playground. So let's go ahead and try this for ourselves. Now we've already chosen the grid map playground here. So I'm just going to go ahead and close out of this sticky note. Close. And I'm going to delete these blocks here. You can do that, or you can start a new blocks project as well. In this case, this was really easy for me to just restart. Now, for all of this, you want to follow along so you can see and code the location sensor yourself. The first thing that we are going to be doing, if I open that playground back up again, is we are going to be driving our robot along the x-axis. So that x-axis is our horizontal axis, and we are driving to the number 5. So if we look, the number 5 is right down here. But what are the coordinates of the number 5? We need to figure that out. So let's go ahead and take a look at our sheet here so we can follow along and see what the coordinates are. So if you remember, I just said we're going to the number 5, which is right down here. Now this, we always label our coordinates with our x-axis first. And if you remember, each square is 200. So we're going to the middle of square 5. So we're going to about negative 100. So 5 is negative 100 for x. And for y, we think it's going all the way down. So 1, 2, 3, 4, 200. So that's 800. And then halfway through this one, so that's an extra negative 100. So we're going to negative 900y. So now that we know our coordinates for the number 5, right up here, negative 100, negative 900, we can start to use that information in our VEXCode VR project. So the first thing we need to do is to turn our robot to face the number 5. Remember, it's right down here. So let's go ahead and move the playground over. And just like we've done before, we're going to turn our robot to the right using a turn 4 block and bring that in. So we're going to turn right to face the number 5. And now we're going to start using those location sensing details in order to navigate our robot to the number 5. So we're going to use a lot of the same blocks as before. We're going to use a drive block paired with a wait until, if you remember, is in the control category. So I can click that and it will scroll down for me. So we're going to drive forward and wait until that position is greater than negative 100. So let's think about this. Why is it greater than negative 100? So our robot is starting here on the 1. We're driving this direction. And so we're moving up the x-axis. We're moving along, so the numbers are getting bigger as we move up the x-axis. As we're going up and the numbers are getting bigger, we want our robot to be noticing that the position in x is greater than negative 100. If it's greater than negative 100, that means it's on this to the right side of the negative 100. Otherwise, we're already less than negative 100, so our robot wouldn't move. So we're going to go greater than negative 100. So let's find the blocks to do that. So we're going to go down to our sensing category, and we're going with our position in X. I'm going to keep that down here because if you notice, this block, this reporter, will report a number. Again, we're talking about these numeric values here, negative 100, negative 900, things like that. But it won't fit inside of our Boolean block. Remember, our Booleans report true or false. So if we scroll down to our operators, if you remember, we want it to be greater than, so we want that greater than symbol. So we want the position in X, which is our reporter, it'll fit right in here, to be greater than negative 100 because we're moving along the X-axis, so we need to use our X value. Once our robot reaches that negative 100 or goes just past it, we want it to stop driving. So we can go back up to the drivetrain category and pull in a stop driving block. So now we've seen how this all works. Let's go ahead and open up our dashboard so we can watch our location working here as well. Let me move this down here so we can see our whole project and the playground. So we're going to run the project, and it's going to turn right, move forward, and you can see here it went until X was negative 90 millimeters. Negative 90 is greater than negative 100. So we've successfully navigated our robot to the number 5. Now, what if we wanted our robot to now go back to the number 1? What do we do next? So let's look back here. So we're already at the number 5. The first thing we need to do is we need our robot to turn around. So it's going to need to turn around 180 degrees. And then it's going to need to go back down to the number 1. So what are the coordinates for the number 1? Do you remember what we saw on the location details before? We also can use this map to help us figure it out. So 1 is negative on the x-axis. So we're going to, x is negative 900, and y is also negative 900. If you remember, we're not changing our y-axis right now. So the number 1 and the number 5. Go ahead and label those for us. So now what we need to do is we need to code our robot to turn around from the number 5, go back down the axis to number 1. So let's start by adding those blocks. So I'm going to go ahead and move my playground window over, and we're going to go ahead and get rid of this stop driving block. If you remember, the first thing that we said was we want to turn right. You can turn right or left because we're turning all the way around. So we want to turn 180 degrees. So that's going to rotate our robot all the way around. Whether you turn right or left doesn't really matter. And now we can add in the same blocks as before. Drive forward, wait until, scroll down for our position block, and then we can pick up our operator. Now, if you remember what we talked about before, as we were moving up the axis towards positive numbers or larger numbers, we're going to use the greater than symbol. In this case, to get to the number 1, we need to move down the axis towards smaller numbers, towards more negative numbers. So for this, we want to use a less than. As you're moving down the axis, you want to use a less than. As you're moving up the axis, you want to use a greater than. So I'm going to use a less than block. So wait until this position in X is less than negative 900 because that's our x coordinate. And then we want our robot to stop driving. I know this is a lot of math, but you are doing so well understanding how our axis changes or how our location values change along these axes. So I'm going to reset my playground, and I want you to watch the location values again. So we're going to, let me move this over. We're going to start the project. The robot's going to turn, drive to the number 5, turn around, and drive back to the number 1. So now you've successfully moved up and down the x-axis. Great job. So now that you've successfully moved up and down the x-axis using the location sensor on the VR robot, what we are going to do is we're going to do a little challenge to drive to the number 8 and then back to the number 4. So let's go ahead and find those coordinates first thing, just like we did before. So first we are driving to the number 8, which is over here. And the number 8 is on the positive x, so it's 1, 2.5, so that's 500. It's right there. So the number 8, x is 500 millimeters. And just like the others, because we haven't moved at all on the y-axis, the y is negative 900 millimeters. So that's our number 8. And then we can look at our number 4. We use a different color for the number 4. The number 4 here, we're moving back down the axes, so we're moving up to the number 8. And then we're going to be moving back down to the number 4. The number 4 has the coordinates of negative 300. So x is negative 300. And just like the others, the y is negative 900 millimeters. So now we can use this information to help us make our project. So we're going to go up to the number 8 to x equals 500. So we're going to be using a greater than because we're moving up the x-axis. We're moving towards larger numbers. We're going to go greater than to up to 500. And then we're going to move down the x-axis to negative 300. So we'll use a less than as we go through. You know, what's really cool actually is if we draw these arrows, the arrows on the end tell us what kind of operator we're going to use. So this direction is greater than, and this direction towards the 4 is less than. So you can actually draw these out and help you remember what kind of operator to use just based on the arrows that you draw to move around the playground. So now what we can do, since we're using the same kind of behaviors, is we actually can use this project as a basis for what we're doing in our moving to the number 8 and then to the number 4. So if we remember, the coordinates for the number 8 are 500, and the x-coordinate for the number 4 is negative 300. So let's walk through this, look at our project real quick, and see if this is going in the right direction. Let me reset the field so we can watch. I'm going to go ahead and close out the dashboard so this makes it a little larger. So let's walk through our project. The robot will turn right for 90 degrees. Drive forward until that position in x is greater than 500, which will take us to 8. It'll turn right for 180 degrees to turn that robot around and start facing back towards the lower numbers. Then it will drive forward until it gets to negative 300 or is less than negative 300, which will take us to the number 4, and then stop driving. So let's go ahead and test that out. We're going to run our project. See our robot turn, move up to the number 8, turn around, and then go back to the number 4. So if we look, we can look at our location sensing details again. So we're at negative 320. Again, this is just a close estimate, but it helps us get onto that number each time. So we can use a lot of these tips and tricks about moving up and down the x-axis the same way with the y-axis. So the same way we drew arrows and that helped show us greater than or less than, we can do that with the y-axis. We just might have to turn our paper so we can see the numbers correctly as we go through. So let's go ahead and start traversing our robot along the y-axis. Let's go ahead. I'm going to reset this. We're going to get rid of our project right now. We're just going to start over as you go through. Now this time, we're going to be navigating our robot to the number 31. So let's go ahead and find our coordinates. So as we look here, the number 31 is just above the 1 straight up on our number grid playground. So we know already our x is going to be the same for all of these numbers. So for this, the x is negative 900. And in this case, our y, we've got 1 block down and then a half to get in the middle. So we've got negative 200, negative 300. So negative 300 is our 31. Go ahead and make sure we're labeling our axes here, or our coordinates. So our robot's going to start at the number 1 and move up the y-axis. So just like before, we can see here it's showing us a greater than because we're moving up the axis. Anytime we're going up the axis towards larger numbers, we're going to use a greater than. So we're going to use a greater than to get to negative 300 on the y-axis. Let's go ahead and build that project together. So now we don't need to turn our robot because we're already facing the number 31. So we can just go ahead and drive forward. Wait until the position in y, so we actually need to change the parameter this time of our position block to y. And we need our position in y to be greater than, move all that in, our position in y to be greater than negative 300. And then once we've reached that position, we want our robot to go ahead and stop driving, just like before. So you can see a lot of parallels here between the other projects that we've done. Our robot is driving forward and waiting until this Boolean, this green operator block, reports as true. So as soon as that position is greater than negative 300, that wait until will report as true, and it will move to the next block, which is our stop driving. So let's go ahead and start our project. It's going to drive forward. It got to negative 280, reported as true, and then stopped driving. So now, just like before, we want our robot to go back to the number 1. So it's made it to 31. Now we want it to turn around and go back down to the number 1, which is right down here. Apologies, my arrows are a little smushed. It's a small map. But if you remember, the number 1 is x negative 900 and y negative 900. Now, since it's moving down the y-axis, should it use a greater than or less than? A less than, yes. So just like in the others, as you're moving down the axis or towards more negative numbers or smaller numbers, you want to use a less than. So we can add on to our project. We can remove our stop driving block. And then we can go ahead and turn right for 180 degrees. Just like before, it doesn't matter what direction you turn, as long as the robot turns around. And then we're going to do the same thing as before. So we're going to drive forward and then wait until that position in Y, on the Y-axis, remember to change that parameter, otherwise it'll mess with your robot, is less than, so we just talked about how this is less than negative 900, and then we're going to go ahead and stop driving, just like before. So let's go ahead and when we run this project, we should see our robot move to the number 31, turn around, and then come back to the number 1 and stop driving. We'll run our project. There we go. So if you saw, it was pausing at negative 270 along the y-axis, and then it turned around 180 degrees and then went back down to the number 1. Now, if you wanted your robot to get even closer to those locations, we can actually use something that we talked about previously, which is our drive velocity. So rather than speeding our robot up, if we slowed it way down to 20% and we run our robot, it's going to move a lot slower. But you can see here it's at 292 and then 908. So the slower the robot goes, the more time the sensor has to report the data, and then the robot can act on that information because of the blocks. It's always going to take some time for the robot to react, but if you wanted to get that even closer, you could slow down the velocity of the robot to do that. I'm going to go ahead and get rid of the drive velocity. It was a cool thing to show, but nothing super important. But now we've gone through and we've driven up and down the y-axis. So we're going to do another little challenge, just like we did before with the x-axis. So now we're going to do the same thing as before, except for this time we're going to be moving up the axis from the number 1 to the number 81. We're going to be moving up. And then we're going to move, ooh, that was a very wobbly line. That's okay. Our robot will drive in a much straighter line. And then we're going to be driving back down to the number 41 here. So let's go ahead and gather our coordinates for 81 and 41. So for 81, we'll put that over here. The x is negative 900, just like before. And our y is on the positive side of the y-axis. So 200, 400, 600, and then we're halfway here, so that's going to take us to positive 700. And then the number 41 is going to be at x, negative 900, just like before. And our y, it's just in the negative y-axis, just barely below. So I can tell that that's negative 100. So now what we can do is we can use these numbers, plug them into our project, and actually solve this challenge. But as we've been going through, we've been making a lot of notes on this extra sheet of paper, rather than making the notes in our project. So how can we make notes like this in our project? We can do that using something called comments. So comments are a type of block. They're at the very bottom here. So I'm going to go ahead all the way down to comments, these gray blocks. And comments are blocks that you can use to type into. So comments are usually added to projects to really explain what a coder wants their project to do. This is really helpful as you're troubleshooting, and it provides context to your code. So now you can think about the overall goals of the project with your comments and then make sure the blocks match. So let me go ahead and I'm going to hide this. So we can drag in a comment block. And the first thing we want our robot to do for this challenge is we want it to drive to 81. And what we can do here is we can put our coordinates. So we know 81 is at negative 900, and then y is 700. So now I can see what my robot is going to do, and then I can go ahead and change my parameters. So I know that the robot first needs to go to 700. After the robot makes it to that number, it needs to turn to face 41, which is our next number. So that's where we're turning right. And then we want our robot to drive to 41. And our coordinates here are negative 900, and then our y is negative 100. So now we can plug those values in to our blocks really easily without having to go back to our notes. So this is giving us a lot of context. So now we could see, if we made a mistake, exactly what part of our project needs to change. So let's go ahead, we'll reset this. We're going to test our project out and have it go to the number 81 and then back to 41. So we'll see our robot go up to 81, turn around, and then go back to 41. So we're also seeing these comments as a way for us to read our project, or it could be a way for someone else to read your project. If you want to share this with a friend or someone else to show them what you've done, they can understand your code even if they don't understand code because you've written out what behaviors the robot is doing. So now that we've learned how to navigate the x-axis and the y-axis using our location sensor, our next big challenge now is to put them together as you drive to 3 numbers on the playground. So you're going to need to drive to the number 25, 42, and 78 in whatever order you choose. Let's go ahead and start this together. We'll do the first number together, and then you can do the others as your challenge. So the first thing we want to do is get the coordinates of our 3 numbers. So I'm going to go ahead and start from left to right and go that way. So the number 42, if we follow this over, it's at negative 900x, or negative 700x, excuse me, it's not all the way over. Negative x is negative 700, and y is negative 100. Then moving on to 25. 25x is, it's just less than the y-axis, so it's negative 100. And the y is all the way down to negative 500. And then finally, 78 is positive 500. X, and also positive 500 on the y. That makes it nice and easy. So now that we have our coordinates, we can start a new project and plug these into our comments. So the first thing I want to do is I'm going to go ahead and get rid of this project. I'm going to close my playground for right now, and all I want to do is put in my comments. So the first thing we have to do is choose what order our robot is going to traverse these 3 numbers. I personally am going to do left to right, just like I did those numbers before. You can do whatever order you want. This is part of that creativity in our problem solving. There's a lot of different ways to solve a challenge, and in this case, we want our robot to drive to 3 numbers, and the order doesn't matter. So I'm going to say drive to 42 first, and that is negative 700, negative 100. Remember, the x always comes first and then the y. I know that I need to drive to 25, which is negative 100, negative 500. And then finally, I need to drive to 78, which is positive 500, positive 500. So now, once you have your comments written, if you wanted to change the order, you could do that. You could go in numeric order, you could go in opposite order, whatever order you want to go in, you can. I'm going to go ahead and do it from left to right on the playground here. So in order to combine everything together that we've done, we need to think about how we want our robot to move around the map. So I'm going to go ahead and remove this so we have that a little bigger. Now our robot is already facing towards the y-axis to move along the y-axis. So I think it's going to be easiest to move the robot along the y-axis first to get to the number 42. Again, you may want to do it a little differently, and that's totally okay. So we want our robot to, I want my robot at least to drive forward, to wait until the position in Y, remember we have to think about what parameter that we're using, is greater than. So why am I using greater than here? I'm using greater than because I'm moving up the y-axis. And we want it to go above negative 100, which I remember here from my parameter, from my comment. Once it reaches that, it should be at the number 41. So we want the robot then to turn right for 90 degrees and then go to 42. But first, I want to test my project frequently so I know what my robot is doing and what to expect. So I'm going to start my project. It'll drive forward to 41, turn, and now it's going to face 42. So now my robot can move along the x-axis. So now we're also moving up the x-axis. So I'm actually going to duplicate these blocks just like how we duplicated for our maze. We get rid of the extra comments. We want to drive forward until the position in x, so I need to change that, is greater than negative 700 because again, I'm moving up the x-axis. And then I want my robot, let me delete this block. I want my robot to stop driving, and then I want it to wait for 1 second. So what does it mean to have your robot wait? The wait block is exactly what it sounds like. What I am having my robot do is to drive to the number 42, stop driving, wait for 1 second so I know that it's on the number 42, and then continue driving to the next number. So it's just another really good way to make sure that your robot is exactly where you want it to be and that your code is executing how you want it to so those behaviors are on the playground. So let's go ahead and test this out, driving to 42. So it's going to drive forward, turn, it gets to the number 42 and it waits. And now I can build the rest of my project. So this is going to be your process for moving to driving through to the number 25 and to the number 78 as well. So go ahead, keep building on your project and come back here once you've coded your robot to drive to the numbers 25, 42, and 78 all in one project using the location sensor. Good luck. Congrats on completing the Drive to 3 Numbers challenge. Let's go ahead and take a look at just one possible solution and walk through it together. Now I have my solution here. If you'll notice, I named it Drive to 3 Numbers because I want to save my challenge in case I wanted to use it later or show it off. For this, I want a little bit more room on my playground to explain what I was talking about. So I'm actually going to close that toolbox. So there's actually a button right down here in the bottom left, and if you select that, it'll close the toolbox so you have a little bit more room on your workspace. So here you can see I added a couple extra comments. I added a comment to say, wait to see if the number is reached, and then moved on from there. So the first thing that happens, let me go ahead and run this, is the robot's driving up the y-axis, up the x-axis to 42, up the x-axis, and then down the y-axis to 25, and then up the x-axis and up the y-axis to get to 78. So I only went down an axis and used the less than one time because I wanted to focus on doing as much as possible in one direction. But you may have had a totally different answer, and that's okay. There's a lot of different ways to solve this challenge because there's so many ways to drive around the playground, and even the order of the numbers that you're going in can make a difference on what your solution looks like. Congratulations on completing the Drive to 3 Numbers challenge again, and for being able to use the location sensor and learning all about how to use it with the VEX Code VR project.